morning, Janet.
Good morning. Good morning, class. We are here to recap lesson 2 this morning. And also, I think we wanted to remind everyone that your first lab is due this Wednesday. What
5
time?
p.m.
5 p.m.
Central Time.
Thanks. Yeah. So if you haven't gotten to that, please make some headway on that this week.
I've also gotten some really good questions from folks, so if you run into any trouble or have any questions while you're going through it, feel free to shoot me an email and we'll get everything worked out.
Great. So it turns out that this morning, Jessica and I arrived here both a little bit hungry, so I hope you don't mind. We're going to have some snacks as we do the recap, okay? What are you having, Jessica?
My snack is composed of one kind of Girl Scout cookie, Thin Mints.
My favorite. Who doesn't like Thin Mints, right?
What about you, Janet?
I'm having a heterogeneous mix of granola. It's called Love Granola. Actually, it's got chunks of chocolate and strawberries and nice toasted oats in that. That goes really well. I don't know that it's really any healthier than yours, though, but it's very good.
All right. Well, we'll get started and go through the topics of the lesson and the questions that everybody had, and we'll work through those. So here we go.
You know what goes really well with granola?
Yogurt?
No. Readings by Turner, your supplemental readings. Check them out.
Definitely.
Okay, so we're going to go through some slides that will help recap some questions that came up with Lesson 2 on landscape evaluation and metrics. Let me just first review the 3 topics and let you know where we're going with some of these recaps. So topic 1 was on why quantify landscape pattern, and we really didn't have any questions from your muddiest points on those, but we'll actually come back to that for your discussion thread. Topic 2 is where the questions came up, and there in this topic on preparing for landscape metrics, we had questions on better defining or illustrating composition and configuration, questions on neighbor rules, and how to calculate metrics. And then topic 3 presented the wolf example, where we had one question about the radii, and Jessica will post a follow-up note to that specific question. Okay, so let's talk a little bit about composition and configuration. We were snacking here on our breakfast, our granola and Thin Mint cookies, and that was actually to illustrate some concepts of composition and configuration. Landscape composition describes what classes are present in a landscape and how much of each is present. So when I translate this to the cookie example, I usually don't use Thin Mints. I usually use a chocolate chip cookie and talk about what kinds of ingredients are in that. Well, actually, it's even better if it's a more diverse cookie, or a cookie with lots of things like raisins and nuts and chocolate chips. So all of those different ingredients, all those chunky ingredients, add to the composition. They're the classes present in that cookie. And the landscape configuration is how the classes are arranged on the landscape. So if you mix your batter really well, you're going to get a nicely dispersed set of ingredients or classes throughout the cookies. The Thin Mints, in fact, don't have as many ingredients, but they're very well mixed, and so you get a very homogeneous configuration. They're spread evenly across the landscape. Whereas my granola was pretty chunky. So the configuration describes how the classes are arranged and often can be used to characterize connectivity or fragmentation. Here are some examples actually on the ground illustrating some of these concepts. This landscape is kind of some kind of dry, patchy grassland landscape. There are some kind of clumps of grass tufts and bare patches, but overall this might be described as a fairly dispersed configuration. compared to one like this where we have very distinct patches and connected corridors of forested vegetation. It appears to be a more patchy landscape than this one. There are different variations of this. Here we have kind of a nice distinct patches in this landscape too, and a lot of heterogeneity, meaning that there are different kinds of patches throughout, and they're kind of mixed across this landscape. It's not that predictable or regular. And you might say that about this landscape too, where there's streams and there's plowed fields and there's open pasture perhaps and woodlands. So it's quite mixed and it's not very regular in the configuration. So composition again describes the variety of elements in the landscape. When we're not looking at a regular photo of a landscape, but we're looking at a remotely sensed image, we're instead looking at pixels. And so it's a variety of different classes or colors of pixels representing different spectral signatures that are translated into land cover classes that make up the composition of the landscape. And the configuration, again, is the pattern or spatial arrangements of those landscape elements. So where are those patches of woodland versus the open fields? How connected are they? How dispersed? What are the kind of, what's the distribution of the density of patches? So one of the questions that you asked was, what does clumped versus dissected mean? Well, let's try to illustrate with this graphic that shows 3 different landscapes. They each contain these 5 patch types, which represent different land cover classifications, illustrated by a different color. So they all have the same composition of those 5 patch types. But clearly they have different configuration or the arrangement of those patches on the landscape. So patch A, the different patch types are pretty dispersed. We might call this a heterogeneous landscape. It has a lot of heterogeneity in that the patches are dispersed from one another. We can measure this by distance between patches of the same type, for example. And it's a bit random. Landscape B has a more regular pattern, but still dispersed of those same patch types. And landscape C, you can see, has a really much more clumpy, or another metric term we use is contagious. It has high contagion in the landscape, and that there's a lot of connectivity between patches of the same type.
So from the lesson, we started talking about calculating landscape metrics or quantifying landscape pattern at 2 different levels. So we can actually quantify landscape pattern at the class level and at the landscape level. So class metrics represent the spatial distribution and pattern within a landscape of a single class type. So most class metrics can be interpreted as fragmentation indices because they measure the configuration of a particular class of vegetation, such as forest or wetland. Whereas landscape metrics represent the spatial pattern of the entire landscape mosaic, all of the classes simultaneously. So most of landscape metrics can be interpreted more broadly as landscape heterogeneity indices because they measure the overall landscape pattern. It's important to interpret each metric in a manner that's appropriate to its scale and the question that you're addressing. So in order to calculate landscape or patch metrics, we have to define a patch. So we generally think of a patch as a nonlinear surface area differing in nature or appearance from its surroundings. So you can see in the illustration here, we have 2 different patches These patches are composed or perhaps of the same kind of land cover type, surrounded by a different land cover type. And in each of these examples, you can see that there's a mosaic of different land cover types, the white area and the darker areas, and those are different patch types. So to perform a metric, you have to tell the program that you're using how you define a patch, and we do that using neighborhood rules. And so we had a little bit of confusion or questions about how you actually use neighborhood rules. And so generally when calculating landscape metrics, there's the 4 neighbor rule or the 8 neighbor rule. The 4 neighbor rule considers a individual, so we're using raster or cell-based data. So for each of these squares of this particular type, so if we take this black square here, and we were going to determine if if it has any of the neighbors that are the same cover type. So we would examine the neighbors on each of its 4 sides. Since it's an edge patch, this is each of its 3 sides. Because none of those patches are the same cover type, which is urban in this case, that patch consists only of a single cell. Now, if we expand this idea and start looking at the white patches, and those are forested land cover type, those patches, and you start counting each of the patches that have a cell adjacent to one of its long edges, then you can develop this really big patch here that's all forested landscape. So if you were going to count the number of forested patches like we have here, you would wind up with 7 forested patches using the 4 neighbor rule. The 8 neighbor rule, on the other hand, considers anything that is adjacent to a cell that's either adjacent, let's find a good example. So if it's adjacent here, so you use the long edges like you did with the 4 neighbor rule, but you also consider anything that's touching at a corner would also be a patch of the same type. So that way, if you start looking at this cell here, this forested patch, this diagonal patch over here that's also forested, those are considered part of the same patch. So using the 8 neighbor rule on this landscape, you end up with a single patch. So some metrics, so you can calculate the number of patches using different neighborhood rules, and you can see that the number of patches is sensitive to the neighborhood rule as well as the mean patch size. So that in these landscapes, your metrics would actually be different depending on the neighborhood rule that you used. Some metrics are not sensitive to the neighborhood rule, like contagion, and we'll get more into that later. So one of the things that we wanted to know is, why do we use landscape metrics? Well, what kind of questions can you answer? And one of the questions that you're going to actually be addressing in your lab this week is, how does a landscape change over time? And so you can compare the metrics, for instance, an early settlement versus a post-settlement landscape, and you can quantify the differences between those landscapes. So we have metrics that can quantify the composition of the landscape or the variety of elements or classes in that landscape and how much of each of them is there. And so landscape metrics for composition include the number of classes present, the proportion that each class occupies on the landscape, the number of patches, and the largest patch index. You can calculate similar things for each class individually. So the total area of an individual class, the number of patches of an individual class, or the mean patch area for that class. Configuration, or how those particular classes are arranged on the landscape, can also be calculated at the landscape or the class level. Landscape metrics for configuration include edge density and patch density, which are related, percent-like adjacencies, which is the likelihood that a patch is adjacent to a neighboring patch of the same type, and contagion. At the class level, you can calculate all of the above metrics for individual land cover classes. So we can choose metrics to represent both composition and configuration at the landscape and the class level. It's best to choose simple, easy to understand metrics. While we don't expect anyone to have to know the formula for calculating a metric in their head, we do provide examples of those in the lesson because it's important to understand how a metric works. So when you start with your question that you want to answer about a particular landscape, think about how you want what things you want to characterize about that landscape. For instance, the number and size of classes present, and the dominance or evenness of those particular classes. You can look at the spatial arrangement of those classes. Are the classes clumped into larger patches or fragmented into many small classes? Are patches of the same class close together or far apart? How many edges are present? So is this landscape more or less crossable, for instance, by a species of conservation concern? Or which classes are most often found close together? So the metrics that you choose should be related right back to this question that you start with. And then you can start looking at which metrics are correlated and how they're going to be able to answer the question that you're asking.
Finally, a question was asked about how we decide which metrics we're going to calculate in ArcGIS or should calculate in ArcGIS versus which we might use FragStats for. And my response to that is, if you're doing any kind of quantifying landscapes, either to compare between times, between two different landscapes or different scenarios, generally you're going to want to calculate a number of different landscape metrics, and the easiest, simplest way to do that is to bring your landscape data into FragStats and run a set of metrics at once within this program. This is a sample menu within the FragStats program. You'll be working with this in lab. And this one shows the landscape level metrics selection window. So right up here we see that we're in the land metrics. These are the different categories of metrics at the landscape level. And we are on the tab here of area density edge. So within this menu we can decide, you can see there's, you know, if you looked across all these tabs, there's quite a few metrics to select from. Here we can select things like number of patches, patch density, largest patch index, total area, total edge, edge density, etc. So you can also select all by just hitting one of these buttons, but that I don't recommend because then you have to make sense of all of those results. So you want to be really thoughtful up front about which metrics are going to give you the kind of information that you want for your landscape analysis. This shows an example applying some FragStats analysis, some landscape metric calculation to a real landscape. The real landscape happens to be Madison, Wisconsin. And these could represent two different time periods of the Madison landscape or the same time taken with two different sensors. It doesn't matter for this. What we're doing is we're comparing these two in terms of a set of metrics. And the idea here is, again, to show you've got the same composition, same set of classes, and you've selected a set of metrics to evaluate and compare these two landscapes. And a nice way to draw this comparison is to array your results in a table like this so that you can quickly compare patch density from landscape 1 to landscape 2.
So to follow up from last week's lesson and a couple of questions, we promised to give a better idea of what crosswalking, how to perform crosswalking, or an example of what crosswalking is like. And so basically, it's translating one classification system to another. You come across this a lot if you're working across different management boundaries or civil boundaries from one state to another. For instance, you might run across two different classifications of land cover data that you might need to translate from one to another. And so there's basically two ways to go about crosswalking. There's the lumping or the splitting. So lumping merges two or more classes into a single new class. So for instance, in our example, you might have 3 classes, hemlock, northern hardwood, and aspen birch stands, that you would lump all of them into one class called northern mixed forest. On the other hand, splitting breaks up a single class into more than one class. So in this example, you might start out with northern mixed forest, and then you might split that into hemlock, northern hardwood, and aspen birch stands. Lumping is generally easier because you require less data, new data, to go from 3 classes into 1, whereas splitting northern mixed forest would require having additional data from one of your classifications to split that into hemlock, northern hardwood, and aspen birch stands. So that wraps up Lesson 2 recap. We're going to end with some discussion points, which will be posted on the discussion forum that we'd like you to respond to over the next week. The first question is, why do we quantify the landscape patterns we see on the landscape? And the second is, we often use landscape and class metrics and find both of them helpful. Can you think of some reasons why we would want to use both? We would also like to direct you to the FragStats PowerPoint that we're going to provide as part of the recap so that you can use this as an additional reference as you're working through the lab.
That about covers it, Jessica. Thanks. Have a good week.
All right, see you in lab.